renditions. So apparently, whatever Oumuamua is, it belongs to a population of objects that is very different than what we expected from rocks based on the solar system. And then if it's artificial, of course, if it's very thin, it doesn't carry as much mass, as much weight as a rock, because a rock is filled and it's much heavier than a light sail. Life could be quite different with infrared eyes on our nearest habitable planet, near the nearest star. And moreover, that planet is most likely tidally locked, so it faces there is a permanent day side and a permanent night side. And on the night side, and there is a sunset strip that separates the two sides. And my daughters argue that would be the place where the real estate value would be the highest, because you can see the sunset forever.
My Alien Life is recorded high atop the Northern Rocky Mountains and is heard all over the world, and you can listen everywhere fine podcasts are found. My website is www.myalienlifepodcast.com. There you'll find links to every episode, stories, photos, and much more. I am your host, Cameron Logan. This is My Alien Life, and the podcast starts right now.
My Alien Life Podcast.
Three, two, one, zero, and liftoff.
Welcome to My Alien Life. I'm Cameron Logan, and I want to remind you to please follow, like, subscribe to the podcast on whatever platform or app you're listening, and please share it with a few friends. You do that, and it makes it so much easier for others to find what I think is a very special show with incredible guests. I normally don't do long introductions, but tonight we have someone who I can't wait for you to meet. Dr. Avi Loeb is the Frank B. Baird Jr. Professor of Science at Harvard University. He received a PhD in plasma physics from the Hebrew University of Jerusalem at age 24. That led him to the first international project supported by the Strategic Defense Initiative, and he was subsequently a long-term member of the Institute for Advanced Study at Princeton. Dr. Loeb has written 8 books, including most recently Extraterrestrial, which is now available for order on Amazon. He has hundreds of papers on a wide range of topics, including black holes, the first stars, the search for extraterrestrial life, and the future of the universe. He has been the longest-serving chair of Harvard's Department of Astronomy, founding director of Harvard's Black Hole Initiative, and director of the Institute of Theory for Computation within the Harvard-Smithsonian Center for Astrophysics. He serves as chair for the Board of Physics and Astronomy of the National Academics. In 2012, Time magazine selected Dr. Loeb as one of the 25 most influential people in space, and in 2020, he was selected among the 14 most inspiring Israelis in the last decade. Professor Avi Loeb, thank you so much for joining me, and welcome.
Thank you for having me.
Absolutely. I know we're pressed for time tonight. You are in demand across the nation, so let's get started. First, I want to thank you for letting me read your book. And just one question. In the late 2017, scientists at a Hawaiian observatory glimpsed an object soaring through our solar system, and it moved so quickly it could only have come from another star. So, Doctor, when you first received notification of what we now called Oumuamua, where were you, and what did that look like? What did that sound like?
Well, I was at my office at Harvard, and just like any other astronomer, I heard the news, and I didn't expect much, because the only thing that surprised me that was that they actually detected it, because a decade earlier, we wrote a paper where we forecasted that the same telescope would not find any interstellar object, because the abundance of such objects should be much smaller if you were to extrapolate based on what we know about the solar system. So if you imagine rocks being ejected from the solar system and all other stars have similar systems around them, you would expect far fewer objects than needed to explain Oumuamua. So that was the only surprise, that it was actually detected. But given that, the natural assumption of all astronomers was that it must be just like the rocks we have already seen within the solar system, either a comet or an asteroid. A comet is a rock that is covered with ice. So when it gets close to the sun, the ice warms up and then evaporates, and you end up with this cometary tail behind it. Most objects in the solar system are of this type, and there are some that are just bare rock. These are called asteroids, and these are leftover rocks from the formation of the solar system. These are the building blocks, if you can think of it as Lego pieces that were put together to make the planets. Some of the Lego pieces were left behind, and that's what we call asteroids or comets. Now, when this object was observed, it turned out that it doesn't look like anything we have seen before. It has a very extreme geometry based on the amount of light that it reflected, sunlight. As it was tumbling around, the amount of light that it reflected changed by a factor of 10. And that means that the best fit to the variation in the amount of light was of a flat object, a pancake-like object, roughly the size of a football field, a few hundred feet, and that is much larger, longer than it is thick. And it wasn't clear what could be the nature of such an object. And then it didn't have any cometary tail around it. So clearly it was not a comet. So that then people said, okay, maybe it's a rock. But then it turned out that it exhibited an extra push away from the sun, in addition to the force of gravity that shaped its orbit. And usually for comets, that extra push is provided by the evaporated gases. But in this case, there was nothing evaporating from it. So the question was, what gives it this extra push? And the only thing I could think of was reflection of sunlight. And for that to be effective, the object needed to be very thin, with a large area for its weight, and sort of like a sail on a boat, except that not being pushed by wind, but rather by reflecting sunlight. And that's called the light sail. And this is a technology that we are currently developing for space exploration. And if indeed it was something of that nature, then it must have been artificial and produced by someone else. I should say that there was, in September 2020, another object found. This one was bound to the sun, moving roughly at the orbit of the Earth, but also exhibiting this extra push without a cometary tail. Turns out that this object was a rocket booster from a NASA mission to the moon, and it did have this extra push because it was very thin, and we know that it's artificial because we made it. The only question about Oumuamua is who made it and why.
Let me ask you this: when it was first observed, what was the initial speed or the estimate of speed, and how close were they to the actual speed when they estimated that?
No, so one can measure the speed because one sees it as a point of light on the sky. So it reflects sunlight, and that's what you detect. And you see how this source of light is moving on the sky, and you can infer the trajectory, the speed by which it moves, and so that was done soon after it was discovered, and it looked as if it's moving too fast to be bound to the sun. So the conclusion was quite robust that it must be interstellar. It was the very first object that we found visiting the vicinity of the Earth, the solar system, that came from outside the solar system, because it just moves too fast to be bound to the sun. And then all these other weird properties showed up. And after they showed up, at some point, after I noticed 6 unusual properties, anomalies, I thought to myself, maybe it's something else. And so I wrote a scientific paper and also a couple of commentaries in Scientific American, where I suggested the possibility that it's artificial.
What was the speed exactly? Was it 58,800 miles per hour?
Not per, yes, miles per hour, yes.
Right.
Something of that magnitude, but of course the speed varies along the trajectory. As it moves away from the sun, it slows down a little bit because of the attractive gravitational force. So when you say a particular speed, it really depends where along the orbit. But that was roughly the speed when it was passing near us or near the sun. Yes.
Now, when it's drifting through space or whatever it's doing, is it in a spiral pattern? Is the length of the object always parallel to the vision that we see it from Earth?
Oh no! So first of all, it's tumbling.
It is tumbling. Okay.
It's tumbling over 8 hours, a much shorter period than the time it takes it to move along its orbit. So it took it several months to pass between the Earth and the Sun, in the vicinity of the Earth. And over that period of a few months, it was tumbling every 8 hours, sort of like a piece of paper tumbling in the wind. Except here, it's the tumbling is a result of the object, having some spin. Who knows from what, but that's what you observe. You observe the brightness of the object varying. It's a source of light. We cannot resolve it with telescopes. It's too small for its distance for us to resolve. That's why we don't have a photograph of it. If we had a photograph, of course, we would know its nature. We would be able to tell if it's a rock or something else. And in principle, we can take a photograph. If we were to discover such an object on its approach to us, then we can send a spacecraft with a camera that will take a photograph. In this case, we discovered it when it was moving away from us. And so it was too late to approach it. It was moving faster than any rocket we could have sent to chase it. Sort of like having a guest for dinner and then realizing the guest is weird after he left through the front door into the dark street. And right now, it's already 1 million times fainter than what it was when it was close to us.
We see an artist's rendition, many of Oumuamua quite often. Do you think that that's affected the way it's been researched? Did people?
No.
Okay.
No, this is an artist's illustration, and
yes.
Actually, I'm not sure where it came from. That it's cigar-shaped, perhaps just from the statement that was made initially that it's 10 times longer than it is wide. Someone imagined the cigar shape. But in fact, when the light curve was analyzed already in the initial discovery paper, but more recently, at the end, in December 2019, there was a very detailed paper that analyzed the variation of the amount of light reflected from Oumuamua as a function of time as it was tumbling, and concluded that at the 91% confidence level, it must have been flat, disc-like or pancake-like rather than cigar-shaped. And that's very important because you don't get such objects easily from a natural origin. And this quality of Oumuamua was pretty much ignored by people that want to believe it's a rock. I should say that in the couple of years after my paper appeared, there were attempts to explain Oumuamua as a natural object. And what the models that people came up with, the scenarios, do always consider something that we have never seen before. For example, there is a suggestion maybe it was a hydrogen iceberg, a frozen hydrogen, so that when it evaporates, we can't see the vapor because hydrogen is transparent. The problem with that is that hydrogen evaporates very quickly. And so we showed in a follow-up work that such an iceberg would not survive the journey. The object will evaporate in interstellar space by absorbing starlight. Another suggestion was maybe it's a collection of dust particles, sort of like a dust bunny that you find at home, and except the size of a football field, and very rarefied, 100 times less dense than air, sort of like a cloud of dust spinning around every 8 hours and floating through space and then being pushed by sunlight. The problem with that is that it's hard to imagine how it would survive if the dust particles are so loosely bound to each other. And then there was a suggestion maybe it's a fragment from the disruption of a bigger object, but that's also quite unlikely because to disrupt an object when it passes through close to a star, requires special circumstances, and also the fragments usually are elongated, like cigar-shaped and not flat. So that just illustrates that anyone that wanted to explain the properties of Oumuamua from a natural origin claimed that it must be something that we have never seen before. And I find those explanations less plausible. And if we contemplate something that we have never seen before, then why not an artificial origin?
Can you describe the expected trajectory when it was near the sun and the deviation, the difference there?
Yeah, so the gravitational force of the sun shapes the orbit of objects around it. And, the planets are moving in nearly a circle around the sun, bound by gravity to the sun. But an object that comes from far away has a different type of orbit. It dives close to the sun and then recedes out away from the solar system. And the orbit of Oumuamua deviated from what you would expect just based on gravity by a small amount, about 0.1%. But it's a very significant amount because to propel an object by that much as a result of cometary activity or evaporation, you need really to evaporate about 1/10 of the mass of the object. About 10% of the weight of the object needs to go into the cometary tail, and that's a lot. You cannot miss a cometary tail that includes 10% of the mass of the object, and we have seen nothing around it, no gas. The Spitzer Space Telescope looked very deeply and couldn't trace any carbon-based molecules or any dust particles around it. So that is very puzzling. Even though there is this deviation, we don't see the gases that usually accompany comets, and so that makes it unusual.
I know the Pan-STARRS telescope in Hawaii proved to be quite remarkable and has made many discoveries above and beyond what they thought it would initially do. But why is this the first? Why are interstellar objects so rare? You kind of jumped into that quickly, but they are rare, very rare, aren't they?
Yes. The point is that in order to see an object, you need it to be big enough so that it will reflect enough sunlight for the telescope to pick it up. And the bigger the object is, the more rare it is. So it's just a question of statistics as to how many such objects you have per unit volume, and then they cross the region around us to which the telescope is sensitive. And if you just take the abundance of rocks of that size, which is of order 100 meters or a few hundred feet, in the solar system, and imagine that a reasonable fraction of them gets kicked out of the solar system, and assume that other stars have similar conditions in them, you can calculate how many such rocks should populate interstellar space and then come to within the range where Pan-STARRS can detect them. And that's what we did a decade earlier, and we concluded that there wouldn't be enough rocks for Pan-STARRS to detect even one. And apparently it did detect. The difference was a factor of many orders of magnitude. I'm talking about 100 to 100 million, depending on assumptions. So apparently, whatever Oumuamua is, it belongs to a population of objects that is very different than what we expected from rocks based on the solar system. And then if it's artificial, of course, if it's very thin, it doesn't carry as much mass, as much weight as a rock, because a rock is filled, and it's much heavier than a light sail, for example.
You used the term kicked out of the solar system a couple of times. What is the most likely scenario that would kick an object out of the solar system? How does that happen?
So that happens when you consider the periphery of the solar system, the outskirts, where, for example, there is the Oort cloud of comets. And these are objects that were kicked far away from the sun, either by Jupiter or by other planets that basically removed them from the inner region of the solar system. And there is sort of a halo of such objects called the Oort cloud surrounding the sun, and it goes roughly halfway to the nearest star. So every star has an Oort cloud, and they almost overlap. They touch each other. And if there is a star passing by near the Oort cloud of the solar system, it can rip apart some of the rocks that used to belong to the sun and basically kick them out by the force of gravity. It basically tears them apart from the solar system. And that's one way of losing those rocks. Now, I should say another property of Oumuamua that was really unusual is that it was at rest in sort of the galactic parking lot, the public parking lot near us. So there is this frame of reference which is called the local standard of rest, where you average over the random motions of all the stars in the vicinity of the sun. And it turns out that Oumuamua was at rest in that frame. And only 1 in 500 stars is so much at rest in that frame. So the relative speed relative to the sun was simply the motion of the sun relative to the local standard of rest. And if you find an object in the local standard of rest, it's just like finding a car parked in a public parking lot. You can't tell where it came from. And Oumuamua, we cannot assign it to any particular star because it was sitting at rest in the local standard of rest. And that's another very peculiar property of it. So there are a set of unusual features of Oumuamua. Each of them is a low likelihood event, and you take small probabilities and multiply them, you end up with an extremely rare object. And the question is, why is it so rare if it's the first object that we discovered from interstellar space? And that makes it quite unusual.
What do we know about looking for them now as we go further into the future? Are we better at spotting something like this?
Yeah, so Pan-STARRS continues to monitor the sky. Its original objective was to find the killer asteroids. These are rocks that are on a collision course with the Earth, near-Earth asteroids. And Congress issued a task to NASA to find 90% of all the objects that are bigger than 140 meters, roughly the size of Oumuamua. And Pan-STARRS started addressing this challenge. It was monitoring the sky, and in the process of doing that, discovered Oumuamua. And the next telescope that will do much better is called the Vera Rubin Observatory, that will have a survey of the sky called the LSST that is far more sensitive than Pan-STARRS was able to conduct. And that, if indeed there is this population of objects, it should find an Oumuamua-like object every month within a few years from now. And so there is something to look forward to, because once we find more of the same, then we can examine those objects much more carefully now that we know about Oumuamua. At least that's what I try to motivate the observers to do. And science is all about reproducibility of results. So if we see a similar object, as peculiar as Oumuamua was, and we study it, we might find its nature.
Assuming this is too fast to be an asteroid, which it is it too slow to be an interstellar spacecraft?
No, it's not too slow. It's you have to understand that it's roughly the speed that you expect from interstellar space, but a spacecraft could potentially move very fast. It could move near the speed of light, and the point is that astronomers will never discover it. Because astronomers seeing something move too fast will not even list it in the catalog that they make. They would say, oh, maybe it's an artifact, maybe it's... So the point is, when you look at data in astronomy, usually people have in mind some type of objects. In the case of pan-stars, they were targeting those dangerous asteroids that may come close to Earth. And so the objects they were looking for are moving roughly at a speed of a few tenths of kilometers per second, and Oumuamua was moving twice as fast or something like that. And that's the range, the kind of velocities they were anticipating and the kind of objects they were looking for. And that's, they find an interstellar object that is not too far removed from the range that they were looking for. But of course, they would never find an object moving close to the speed of light. And it's possible that there are such objects. I'm leading a project called Starshot, and the goal there is to reach the nearest star, Proxima Centauri, within our lifetime, within a couple of decades. And the only way to do that is by launching a spacecraft at a fifth of the speed of light, because the distance to the nearest star is 4 light years. And so there is a technology that allows us to do that, and that's the light sail technology. If we produce a very powerful laser beam that shines on a lightweight light sail, then if the sail weighs less than a gram, in principle, you can construct a laser powerful enough to boost it up to a fraction of the speed of light. And such an object that weighs a few grams and moves close to the speed of light would never be detected by existing telescopes on Earth. And there could be such probes passing through the solar system. We are just not aware of them.
Has the maximum speed of an asteroid ever been determined? And then is that number important?
Within the solar system, it cannot exceed a certain value, which is called the escape speed from wherever you detect it. There is a certain speed above which an object will escape from the sun. And so all the bound asteroids are with speeds slower than that. So whenever we find something above this speed, it means that it came from interstellar space, and Oumuamua is an example. So Oumuamua is moving much faster than all the asteroids that we have seen that were bound to the sun.
Interesting. So if we have an interstellar object that's making these incredible speeds and exceeding what we would normally expect, really you're talking about two objects colliding. This other piece of an object goes at an undetermined speed throughout interstellar space. Can it exceed its initial speed somehow naturally, or is it always slowing down?
You mean when it enters?
Right, when two objects collide and basically one of them goes into interstellar space, just like Oumuamua, is it naturally slowing down all the time when it's out in deep space without gravitational pull?
Well, in deep space, there are two forces that act on an object. One is the force of gravity from stars that it passes near. And the second one is the friction force on the interstellar medium. There is a gas in between the stars that could potentially slow down objects. But when we examine this, the effect of the friction with the gas in between stars is not very significant for an object like Oumuamua. So it's completely secondary. And the main force that is acting on such an object is the force of gravity.
space travel requires us to speed up and to slow down, and that's what we know. What else is there? I mean, how else can we could this object be? How could it speed up? How could it slow down if it's a natural object? If it's a object made by some type of organism that we've never encountered, obviously.
Well, if it's natural, if it's a rock, then it could speed up or slow down by, for example, a slingshot effect close to a system that has two bodies, like a planet like Jupiter and a star like the Sun. Then, in principle, when it passes in between them or comes close to Jupiter, Jupiter can give it a kick through gravitational force, and that happens, and that could also trap objects that come from outside the solar system. Now, you could, in principle, launch objects to very high speeds if instead of Jupiter and the Sun, you have, for example, two black holes, because black holes are, in principle, can produce speeds that are up to the speed of light near them. So in principle, gravity can give you kick velocities that are arbitrary, all the way to the speed of light. But so the speed itself is not a discriminant that will tell you this object is natural versus another object is artificial. It's the properties of the object. In this case, that there was this extra push that it exhibited without a cometary tail that requires it to be quite thin, and it's extreme geometry that imply that maybe it's artificial. So I would, rely mostly on the other properties, not so much the speed that it was moving, in arguing that it may be artificial.
So do you feel that space travel is obtainable if we use a system of speeding up to getting as close as we can to light speed and then slowing down again, or does there have to be something else?
No, I think, it depends on how patient you are.
Exactly.
And by the way, humans are not really designed for very long journeys.
No.
And there is it's not at all clear that you can transport humans across in between stars, but you may not need to, because in principle, you can launch a computer system together with a 3D printer and load the human DNA on the computer, and in the more distant future, we might be able to produce synthetic life out of the raw materials that exist on another planet. So instead of transporting humans, you can send electronic equipment that can survive long journeys and is not much affected by the harsh environment of space, and then reproduce life as we know it on other planets synthetically. And this is not science fiction, because right now at Harvard University, one of my colleagues, Jack Shostak, who got the Nobel Prize, is working on producing a synthetic cell in the laboratory out of chemical ingredients that this is an attempt to reproduce the process that created life on Earth out of a soup of chemicals.
So in our known universe, of which may contain more than 1 trillion stars, do you feel that the universe could figuratively be teeming with life?
Yeah, actually, the universe contains 1 trillion galaxies, and each galaxy contains billions of stars. So altogether, it's 10 to the power 20 or more stars with planets similar to the Earth around them. And it's more than the number of grains of sand on all beaches on Earth. So to me, at least, it implies that we should be modest, because anything we accomplish here on Earth, it's just like sitting on a grain of sand in the landscape of a huge beach. It's not very significant, and you always need to keep a modest perspective. And beyond that, we live for such a short time relative to the age of the universe or the age of the sun. And so by looking at the sky, you actually learn to be modest. not to think so highly of yourself. And I think the other aspect of this is humans throughout history used to think that we are at the center of the universe, that we are unique and special. And that's similar to my daughters when they were young. They tended to think the same way, but then they went to kindergarten and met other kids and realized, that they are not unique and that other kids have qualities that are better than theirs. And so they developed a new perspective. And for us to mature as a civilization, we have to find evidence for others.
Do you ever surmise that there could be another possible way for an organism on another planet to evolve? I mean, we consider that we take natural selection and evolution for granted. We don't consider the time needed and the distinction of a single mutation among billions of mutations that either get lost or die in a particular species. But could there be another way? I know there could be, but have you ever thought of that?
Yeah, definitely. I mean, I think we will be shocked once we encounter life forms on other planets, if they are biological, because first of all, the conditions could be quite different. For example, the nearest star, Proxima Centauri, is a dwarf star, and it has half the temperature of the sun on its surface, and it emits mostly infrared radiation. And there is actually a habitable planet next to it. Since the star is so faint, the planet is 20 times closer and still has roughly the same surface temperature as the Earth. And because that star emits mostly infrared radiation, that if there is any creature living on its surface, it would need the infrared eyes rather than the kind of eyes we find on Earth, because we are using visible light because that's what the sun provides us with. But that star provides infrared radiation. And, if there is any grass growing there, it will not look green at all. It would look dark red. And that may be the reason why interstellar travel agencies never find the solar or the Earth as an attractive destination, because if most of the animals in the galaxy have infrared eyes, they would prefer to go to a place, they would enjoy a place that has dark red grass, not a place that has green grass. So our neighbors' grass may not be greener than ours, but it may be more attractive to most forms of life in the galaxy, because most stars are just like Proxima Centauri, the dwarf stars. So here is an example of how life could be quite different with infrared eyes on our nearest star planet, habitable planet near the nearest star. And moreover, that planet is most likely tidally locked, so it faces there is a permanent day side and a permanent night side. And on the night side, who knows how the animals would look like. And there is a sunset strip that separates the two sides. And my daughters argue that would be the place where the real estate value would be the highest, because you can see the sunset forever.
So when you mention such a different place like that and a different planet, it makes me wonder. We're in the solar system where we have so many different planets that are so unique to themselves. Why does that happen? How does that happen? How do we have, if you took 7 of our planets and you compared them side by side, they're so different. The size is so different. The mass is so different. Everything's different. How does that happen?
Well, it's just like in Lego. When you have building blocks, these were planetesimals. You can put them together and make different size objects out of them. And also, there are 2 types of planets. There are these rocky planets like the Earth, and there are so-called gas giants like Jupiter. And
sure.
The gas giants contain, we think, a core that is rocky, just like the Earth, roughly comparable mass. And but it was dressed up with hydrogen and helium because it was situated in the outer part of the solar system. So sort of you build up those planets. Now, one thing I should say about life as we know it, that even if you consider a planet like the Earth, same conditions around another star that is just like the sun, same conditions. Still, you can get life to develop quite differently than on Earth because, if you look at recipe books for cakes, you can start from the same ingredients and end up with very different cakes, depending on how you put the ingredients together and the order by which you add them up and how much heat you apply and so forth. And it's quite possible that you would get very different forms of life, depending on the exact history of each planet and how the chemicals were mixed. Not to speak about the fact that you could have different abundances of these ingredients. And it could be quite interesting to monitor what kind of life develops around different stars. And I have actually a textbook that we wrote with my former postdoc, Manasvi Lingam, that describes everything we know about life around other stars or what we expect it to be. And it will come out in 6 months. So that's a book separate from the one that I will publish next week. And it is a textbook, a scientific textbook. And I very much, we are just now at the beginning of this field of astrobiology. And hopefully in the coming years and decades, we will learn much more about life elsewhere. We will find evidence for it. It will give us a better perspective about our own life and about our aspirations. And I would hope that once we find evidence for life elsewhere, that humans will come together. And because it would look a bit childish for us to fight with each other about resources, about borders, about territories, and all the kind of things that we are wasting our energy on right now. And we would feel part of the same team witnessing life elsewhere.
I have two more questions for you. From an observer outside of our solar system, if we were being looked at, per se, by or researched by another universal species, does our solar system have noticeable markers or attributes visible from great distances that make us look unique among the trillions and trillions of solar systems?
Not really, because as I mentioned before, by now we have a census of planets around other stars, and the Earth-Sun combination is not extremely rare. It's quite typical. So it sort of boils down to the Copernican principle that argued that we're not at the center of the universe and we are not at a privileged location. So if we look at our backyard and see the sun and see the earth, that kind of an arrangement is not unusual in the Milky Way. Of course, most of the stars are not like the sun. Most of the stars are dwarf stars like Proxima Centauri. And there is an interesting question of whether they can support life because they have different properties. They're fainter. They vary a lot. But Earth-Sun situation or systems are not rare at all. And, that again, is the perspective you would assume if we were modest. But people tend to believe that they are special, and that's why there is a lot of resistance to even discussing technological signatures by other civilizations currently in the scientific community. There is a taboo on funding such searches. Very little funding is allocated. And young people are discouraged from including such discussions in papers. And that's unfortunate because if there is no funding and young people are not entering this field, then obviously we will not discover. It's sort of like putting blinders or stepping on the grass and then saying, look, the grass doesn't grow. I mean, given that the public is so excited about the question, are we alone? Are we the smartest kid on the block? I think the scientific community has an obligation to address this issue with all the tools that we have.
When we use a tool like the Hubble telescope, we cannot possibly look at even a small fraction of the objects in outer space in billions of lifetimes. But if astrophysicists face such a large number of unknown anomalies in outer space that they can't explain, do they ignore one incredibly notable discovery over another because they think it's harder to explain or easier to explain? Is there a space anomaly triage where you decide how to and what to research?
I think there is a tendency among astronomers to basically brush anomalies under the rug or carpet of conservatism, basically saying, let's remain in our comfort zone and not even consider things that violate what we expected. And just to give you an example about Oumuamua, there was a seminar at Harvard about the object, and after the talk was over, when I left the room, I left it with another colleague of mine that worked for many years on rocks in the solar system. And the colleague said, this object is so weird, I wish it never existed. And to me, that signifies the approach that many people in the mainstream take. It's a nuisance for them. It bothers them to consider something that doesn't quite fit to the previous notions they had. And I think that's an inappropriate approach, because we should have gratitude to nature for educating us that what we thought about before is incorrect. And we should listen to nature. It's a dialogue with nature. And very often the discoveries and the breakthroughs come from anomalies that don't quite fit what we expected. And I regard Oumuamua as one. And that's why, I insist on discussing it, because it may open our eyes to the fact that we are not alone.
Exactly. Okay, here we go. So, in your opinion, what is Oumuamua, and is there one thing that is unique about it that science can't deny or will not be able to explain?
Yes, it doesn't look like a comet. It doesn't look like an asteroid. It looks like something else. And that something else may very well be manufactured artificially by another civilization. And just like walking on the beach, most of the time we find rocks or seashells that were naturally produced, but every now and then we encounter a plastic bottle that indicates that a civilization must have produced it in our neighborhood. And we should be alert to that possibility, because we could learn something from those civilizations. At the very least, if they are not around anymore, if they died because they destroyed their planet, destroyed the climate, or went into war or something, that could teach us a lesson of how to get our act together and not share the same fate.
Excellent. Tonight, when everyone gets a chance, I'd like you to go to Amazon and please read at least the excerpt that's in Avi's book, because it's something that you won't want to put down. I didn't put it down. Read the whole thing cover to cover in a day, and pre-order it now so you don't have to wait. Dr. Avi Loeb, I'm grateful for our time together, and I look forward to reading your book again and seeing what you discover next. So, Dr. Avi Loeb, thank you so much.
And your questions were excellent. I really enjoyed it. Thank you for having me.
You can find my website at www.myalienlifepodcast.com, and please subscribe to my latest downloads at iTunes, Spotify, Stitcher, and at podbean.com. And please follow me and like me on Facebook and Twitter. My Alien Life is written and produced for broadcast at Studio 254 in the Northern Rocky Mountains. The music you are hearing is produced and created by Elion. You can find all Elion's work online at Heart Dance Records.